This is Dr. Anthony Maddox. I want to thank you for visiting with me and my colleague, Dr. Fred Frecking, for whom I'm speaking. And we're the people that are going to be guiding the STEM Innovation Laboratory for the EDD thematic group. And we appreciate an opportunity just to speak with you a little bit about what we see and how we believe the STEM lab can actually work well with you and the things that you want to try to achieve in your dissertation and to finish up your doctoral work here at the Reseda School. Well, honestly, Dr. Frecking's a neuroscientist and I'm an engineer, and we see STEM as not just disciplines of physical sciences, engineering, technology, and mathematics, but we also see STEM as a way of thinking. We see it as one of many different kinds of ways to achieve interdisciplinary results, to think across various disciplines and use the ideas from various disciplines to solve problems. So for the four concentrations, TEMS, K-12, higher ed, and ed psychology, if you will, in the Reseda School, we think that STEM is a good way of thinking about solving those problems. But it doesn't mean that you have to actually look at physical sciences and engineering and all that per se. It means we can use the principles behind STEM as a lens through which we can now start to solve very complex problems. So that's what we really want to do. And for example, you can really think about sciences beyond the physical and natural sciences. You can think of the sciences of data science, you can think of sciences of social sciences, economics, other things like that, psychology. You can also think of engineering as design process, a kind of a design science. And to frame it, we can actually suggest to you that it's design under constraint. We can also suggest technology is the product of the two. You take a rigorous science of any type and you actually now start to design something under a certain constraint. Then you can find yourself creating an artifact, if you will. And there's always the use or utility of an analytical framework. So you can look at mathematics and expand that as pattern matching or some type of computational approach. You can certainly look at it even as qualitative reasoning, because the process of qualitative analysis has certain pattern matching and coding kinds of aspects to it, which is mathematical. You can also see it as a statistical process or ways in which you can use statistics to help solve those problems too, and many others. So imagine thinking about those four dimensions of solving your dissertation problem, or being able to explore the phenomena that you want to actually, phenomenon I should say, that you actually want to explore, and then you'll have a sense of what the STEM lab is about. It has to be a play space in some respects. It has to be a sandbox or maker space. It has to be a place where you start to play around with ideas, you search for your own problem, you search for your own dissertation, find something that you're passionate about in the core areas, map that to a certain organization that you might work for. You might see something that maybe others don't see, or something you just had a hankering to explore. Then you leverage all your coursework, pull it all together, and then while you're finishing your coursework, and you start to explore these ideas. So we think that STEM is a reasonable way to look at a wide variety of solutions to problems, a wide variety of ways to experiment with and explore lots of different kinds of phenomena, and that's why we're promoting STEM in this kind of way. So you need not be afraid of that. You can actually, those of you who may not have a penchant for mathematics, or maybe always wondered about STEM and maybe a little shied away a little bit from STEM, then we can now start to say to you, yes, you can certainly feel free to explore with us and use the space appropriately. And I must admit, being an engineer in an ed school, and for Dr. Frecking being a neuroscientist in an ed school, and both of us being teacher educators, we see the broader picture. We see the fact that we can now integrate the things that we've loved and have studied a large part of our life, if you will, and start to apply that in this space. Yes, it means working hard. It also means having fun. It also means looking across various disciplines and pulling out a variety of different kinds of ideas about creativity, ideas about innovation, and entrepreneurship. So we're hoping that the students who would agree to work and study with us have that kind of ilk, if you will. They see ways to put things together in new and fabulous ways. At the same time, they may not see those ways, and this is a space they can use to play with those ideas. So hopefully that's something that we can try to achieve in the STEM lab. I have been an engineering professor for a number of years, and that perspective has helped. I am a member of the Research Council of the Annenberg Innovation Laboratory, and Dr. Frecking has agreed to allow us to kind of merge the ideas with the Reseda School and looking at what the Innovation Lab does in Annenberg and recreate some of that in this particular space for a thematic group. And it's an amazing space where they explore new ideas around media, entertainment, and sports. We can do the same thing in education in the 4 concentration areas that we're speaking of and that you know very well. And we can start to move ideas around in different ways. You'll see in the write-up that we want to try to take a gallery walk. We want to go to the Stevens Institute. We want to go to the Viterbi Garage. We want to go to the Annenberg Innovation Laboratory. We want to go to the Iveen Young Academy and other places like the Blackstone Launchpad and figure out ways how they innovate, how they encourage students to innovate, and kind of reproduce those things within the scope of this particular laboratory. So the STEM Lab is a space, again, that you don't have to do science, technology, engineering, mathematics the way you may have initially understood it. But what you can do is you can relax that from physical sciences, relax that from engineering as it applies to using the mathematics and physical sciences to solve problems. Relax the notion of what a technology is, and also relax the notion of analysis to kind of come together with various ideas. No, you don't have to actually have all 4 disciplines in mind when you actually try to solve a problem or explore a phenomena. We want you just to be able to brainstorm and look at various ways in which various sciences and technologies and design, if you will, and analysis can come together. For those of you who want to write a piece of code or learn how to code, you can write an app, for example, for a smartphone. Test it out in an environment, K-12, higher ed, teacher ed, or maybe even ed psych. You can explore the literature on data science and neuroscience or the learning sciences, for example, and pull things together. So it really should be a fun space. It really should be a space where it's wide open in some respects. It addresses what we call ill-formed problems that don't have a single solution, if you will, but we want to, and we're confident we can actually work with you to converge your ideas, to kind of work together as a group, to get things down to a manageable level, to see your way through to finish the degree in the time frame that we all hope that you would. And so we're committed to doing that, committed to you and making that happen. And it's exciting. So if you read the write-up that we produced and kind of listened to this video and are interested, even if you may be just slightly interested, we invite you to stop by and talk with us in a couple of weeks, I guess, or maybe a few days, to kind of talk with us about how that works and ask us questions about time frame, ask us questions about what the preparation is and what your perspectives are around STEM. And I'll end with this. The Next Generation Science Standards now include engineering with science, and that is rolling out to many, many schools nationwide. What that suggests to us is that there needs to be a little bit of scientific thinking and engineering thinking, as well as I might say design thinking and technological development and mathematical analysis in all of us to some small, maybe minor degree. So how do we now start to encourage people to pull all that together to kind of get a different view of the world, how to solve problems? And you may find that you can actually do some amazing things by looking at interdisciplinarity with a broad brush, integrating all the things that you've learned, experiences you've brought to the Rasir School, as well as the courses you've taken, and then figure out ways to kind of look for new problems, and whether they be traditional solutions, whether they be incremental solutions in terms of incremental innovation, whether or not they are kind of radically innovative, or for that matter, disruptively innovative. And so we should explore all those different paths and possibilities and see how we may be able to work together to create some fantastic kinds of studies, to explore some new ideas. And again, the output, the outcome, if you will, and takeaway of this more than anything else is that you own your own dissertation. You look for it, you find it, you integrate your coursework, we guide you, you pull it together, you do a great study, and you move the world forward just a little bit. So that's what the STEM Lab is about. Come join us, come learn more about us and about the lab, and we welcome you to do so whenever you get the opportunity. Again, thanks for taking the time to listen to this video, and we always wish you well regardless of what you do. And again, thanks for choosing USC, and thanks for also being in the Rasir School. Hope to see you soon.